Hello, everyone, and welcome to your explanation of worksheet 1B. With this video, or with this worksheet that we're going to do today, this is basically over SOHCAHTOA. And if you remember back to Algebra 2, you probably did this in Algebra 1, I believe, and definitely in geometry. These are all the relationships that we use in order to solve for things that are missing in right triangles. So at the very beginning of this worksheet, there's a blank portion of notes, and here's what you're meant to write in the notes. Basically, sine is the with this picture we have that angle theta, and all of these relationships are assuming that that's the angle you're looking for. So we have a side that's opposite of that theta, which is across the triangle. We have a side that's adjacent, which is adjacent means next to. And then there's a hypotenuse, and the hypotenuse is always the longest side of your triangle, and it's always across from your 90-degree angle. So these are all the relationships, and I highly encourage you to write these down. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Those are the ones we're going to use today. I put the inverse ones over on the right side, so the cosecant, the secant, and the cotangents. We won't be using those today at all, but I thought it would be I thought it was important to include those just so that you're aware of them. So go ahead, pause the video if you need to, and just write those down. But once you have those, let's move on. Okay, so let's go to, what number are we going to do first? Okay, so in the first section, this is really easy. All you're doing in this section is you're just looking for the missing angle. You don't have to find anything else, any other sides or whatever. We're just looking for the theta in each of these. And it does say to round to the nearest tenth, so all of these I've rounded to the decimal and then one additional number. So just one additional number for all of these. Okay, so for the first one, number one, we're looking for this theta. We have, and I guess the hardest thing in all these is deciding what, or figuring out what they gave you. They gave you the hypotenuse in this case and the adjacent. So that 12 is next to our theta, 13 is the hypotenuse of that triangle. And so we're going to use cosine because cosine involves adjacent and hypotenuse. None of the other ones have those. So we set it up. I wrote it out. Cosine of theta equals adjacent over hypotenuse. I plug in the 12 in the right spot and 13 in the right spot. And then from there, a lot of people get confused on what to do. Well, to get rid of the cosine of theta and have just theta, which is what I'm looking for, I'm going to do the inverse cosine of both sides. Inverse cosine and cosine cancel each other out, and I'm left with just the theta on the left side, which is what I want. And then when you do inverse cosine on your calculator, usually it's like second cosine. It's usually above the cosine, but make sure you have some type of calculator in front of you or on your computer or on your phone that has inverse trig functions, because not all of them have that. So, and the other thing is on your calculator, make sure you're in degrees, or else it's going to give it to you in radians or something else. So a lot of times you'll hit the mode button and it'll say, what mode do you want it in, and you just switch to degrees, which is usually DEG for degrees. So if you do all that correctly, plug it into the calculator, you should get 22.6 or something like that. And make sure you put degrees on there and you're good to go. Okay. Number two, very, very similar thing. We look at theta and we say, well, what'd they give us? They gave us the side opposite of that theta, which is the 4. And they gave us the adjacent, which is the 13, because it's next to that angle. We don't know the hypotenuse, and we frankly don't care on this one, because all we're looking for is that angle. So opposite and adjacent are tangent things. So I'm going to do tangent of theta equals our opposite over adjacent. So in this case, opposite is 4, adjacent is 13. And that's how I set it up. Inverse tangent both sides, and you end up with 17.1 degrees. Okay, so the first 6 problems are just finding the angle. So they're all really, really similar. So I'm going to go ahead and skip up to number 7. So in this section it says find the side now. We're looking for a side rather than an angle, and round to the nearest tenth once again. So for this first one, they gave us the angle of 32 degrees. We're looking for the side that's opposite of that, and they gave us the adjacent side to that. So we're going to plug these into our tangent setup. So tangent of 32 degrees is the same thing, or equal to the opposite side divided by our adjacent side. So x divided by 13. So in this case, to get rid of the 13 on that's dividing the x, we multiply both sides by 13, and you're going to end up with 13 times the tangent of 32. You're going to plug that into your calculator, and you're going to get something that's about 8.1. They don't give us any units, so we just call it 8.1, and it's rounded to the nearest tenth, so we're good to go. Let's look at number 8 real quick. On this one, they gave us 60 degrees. The side next to it is what we're looking for, so that's the adjacent. And then they also gave us the hypotenuse. So in this case, we're going to use cosine because that involves adjacent and a hypotenuse. So we set it up with like this. We have cosine of 60 equals our mystery side divided by 11. Multiply both sides by the 11 and plug it into a calculator, and you should get about 5.5. So there we go. All right, so the rest of those in that section are really, really similar to that. So work through those and make sure you know how to do them. All right, number 13. So what number 13 says is solve the entire triangle. So they give you a side length, they give you an angle, and they want you to find everything else. So we're going to find the missing angle, because we know 2 angles. We need to find the third one. And then we're going to find the 2 missing sides. Now, there's a couple ways to do this. I'm going to show you the way I think you should do it. But if you want to use like Pythagorean theorem or something else, you can, and you'll probably get something very, very similar. But just be very, very careful when you're plugging into a calculator not to round too much before you get to your final answer. So the first thing I do on all these, because it's so easy, is I find the third angle. If you remember back to geometry, all the angles in that triangle have to add up to 180 degrees. So we know that angles A, B, and C all have to add up to 180. We don't know angle A, that's what we're looking for. We do know the 62, we do know angle C is 90 degrees. So I plug all those in, subtract them all to the other side, and you end up with angle A is 28 degrees. So now I have all the angles, now I got to find all the sides. And this is super duper similar to what we were doing on the previous problems. First one, I'm going to use tangents of 62 degrees. They gave me the opposite side, so that's why the 22.6 goes up top. And I'm looking for the adjacent side, so that I called it BC, like you would in geometry. So I solved that by dividing 22.6 by the tangent of 62, and you end up getting 12.0 miles for that one. And then really, really similar for finding the hypotenuse. I know my opposite side, and I'm looking for the hypotenuse, so I set it up really, really similar to that, and you end up with a side length of 25.6 miles. Now, a really, really good habit to get into with all of these problems is look at your answers at the end. I rewrote mine on top on the triangle, and your hypotenuse is always supposed to be the longest side. In this one, you know, the 22 looks longer than the 12, and it's supposed to be longer, so that looks right. And then your sides, big sides are across from big angles. So the 28 degrees is across from the 12, and that's the small side. 62 is across from the 22.6, and that's bigger. And then the hypotenuse, like I said, always has to be the longest side. So that looks pretty believable with those numbers. So I always kind of do that, especially like on an ACT or SAT test, just to make sure it makes sense. Because a lot of times you do a whole bunch of work and you plug it in, or you have an answer and it doesn't make any sense. So just make sure it makes sense at the end. All right, number 20. Same thing. We're looking for our missing angle and 2 missing sides. So I started with the angle first. All the angles have to add up to 180. So I subtracted 28 and 90 from 180, and I got 62. So that's angle A. I did the cosine of 28 because I have the adjacent, and I was looking for the hypotenuse, and I found that to be 6.8. And then last but not least, I was looking for the line AC, and I used tangent because I knew the adjacent. I was looking for the opposite, and solved that up, and we ended up with 3.2 inches. So that is the entire triangle. So that is it for this worksheet. It's pretty straightforward, but like I said, the practice is going to get you a lot quicker at these. I put an answer key on Schoology, so that's good to go. Check your work on there, and I showed all of my work, not just the answers, but I showed all of my work. If you find any mistakes on there, sometimes I make mistakes and I don't catch them. Email me and I'll fix it. But other than that, it should be good. Email me with any questions, or talk to a friend, or go to YouTube and watch some videos. But other than that, I'll see you later.